Hey sir, so this is the first video of the Metabolism CPT explaining the pyruvate oxidation process. So pyruvate is the final product of glycolysis, and pyruvate as a molecule is a branching point. There are three different fates for pyruvate depending on the environmental conditions. If oxygen is present, then pyruvate molecule will go into pyruvate oxidation, and pyruvate oxidation has three key steps. So the first step, before anything can happen, is the movement of pyruvate from the cytosol into the mitochondria via a transport protein. Because of how pyruvate is a rather large molecule and cannot naturally diffuse through the membrane of the mitochondria. So the pyruvate molecule will have to attach to this transport protein in the cytosol, and then it will be brought into the mitochondria. Once that happens, this is where pyruvate oxidation really begins. So the first step is the removal of a carbon dioxide known as decarboxylation. So you can see, if you picture pyruvate being here, it'll lose its carbon dioxide, and after that it moves on to a secondary step where it is oxidized, meaning that it loses its electrons. And in order for that to happen, the molecule NAD plus is reduced and gains these electrons and subsequently becomes NADH. So you can see, as the molecule moves down the chain, it's going to lose its carbon dioxide, and it's also going to lose its electrons, and it's going to give them to NAD+, which it becomes NADH. As the electrons move, so do the hydrogen atoms from the molecule, and this is where you see, the hydrogen atoms from the original pyruvate molecule are also going to go to NADH. And the third step is the addition of a coenzyme A, which will bind to the molecule, resulting in acetyl-CoA. So when coenzyme A in the mitochondria will then bind to the resulting molecule after it's gone through these two steps, and then it will become acetyl-CoA. And so if you want to take a look down here, and this is the word reaction for the pyruvate oxidation process. So we would have one pyruvate plus NAD plus CoA, which then yields acetyl-CoA, one molecule of NADH, one molecule of CO2, and a single hydrogen ion. That's it. Thanks.